So for number 22 in this set, we are asked to find the lines that are tangent and normal to the curve at the given point. So if we want to find the equations that are tangent and normal, we've got to start by finding the derivative. So step 1, derivative with respect to x on both sides. I have 2x. Then now, so you can keep this minus square root 3 out as a factor and then consider the xy as a function and then bring the negative square root 3 down. Or you can consider the negative square root 3x to be the function f in this product rule and just y to be the function g. I'm going to handle it that way, but there are different ways, algebraically to handle it. So, but either way, you have a product here, right? This one function times another. There's got to be a product there. So we got to be thinking product rule, f prime g plus f g prime. All right, so when I do f prime, so this is f prime, my f does not have a y in it, so there will be no dy dx, even though I'm doing derivative. So the derivative of negative square root 3x is negative square root 3. All right, and then when I do g, okay, I'm just putting g, so it's not a derivative. So I'm going to put y, but I'm not going to put dy dx because the g is not a derivative. All right, now I'm still doing the product rule. So now I've got to do, I'm just going to copy down the f because it's f, so negative square root 3x, negative square root 3x, and then I need g prime. So g prime, I have g as a function in y, and I'm doing g prime, so I'm doing the derivative of a function in y with respect to x. I need the dy dx. So you could just put dy dx here if you're getting good at this already. I'm going to go ahead and say, all right, I know the derivative of y is 1, and then because this is a derivative of a function in y with respect to x, I'm going to put the dy dx on there. All right, and then I have plus 2y squared, so that's going to be plus 4y, and because it's a function in y, it gets a dy dx. I'm going to not forget that when I do derivative of 5, it's 0, right? And remember to do that derivative. It's a common mistake to copy that down as 5. So that's your step 1. We did the derivative on both sides. All right, step 2, we want all dy dx's on the left and everything else on the right. So what have I got that's a dy dx? I've got, let's get a contrasty color. I have like a pink, that'll work. So this is a dy dx, it's going to stay. This is a dy dx, it's going to stay. Everything else is going to go to the right. All right, so we're going to keep negative square root 3x. I'll clean this up as I go. Dy dx plus 4y dy dx equals, and then these guys are going to go to the right because they don't have dy dx. So negative 2x plus square root 3y. All right, that was my step 2. Dy dx is to the left, everybody else to the right. Step 3, we're going to factor out dy dx. So we're going to factor out the dy dx and have negative square root 3x plus 4y equals negative 2x plus square root 3y. That is my step 3. And my final step 4 is I'm going to divide. So then I will have dy dx equals negative square root 3, oh shoot. This goes on top. Negative 2x plus square root 3y over negative square root 3x plus 4y. I should look to see if there's any way to simplify that. There's not. Okay, now that's just getting the derivative. Now I want the lines that are tangent and normal at this point. So I'm going to say, what is the derivative evaluated at the point square root 3, 2. Sometimes it helps me to make a little note to myself that this is x and this is y, because it can get pretty confusing plugging them in there. I'm easily confused. So when I write negative 2x, I'm going to write negative 2 square root 3, and then plus square root 3y, so that's going to be plus square root 3 times 2, 2 square root 3. Oh, this whole thing is 0. How disappointing. But I need to check to make sure the denominator is not 0. Because, by the way, if the denominator is not 0, I'm already done here. I already know dy dx is 0, regardless of what the denominator is. But I need to check to make sure that denominator is not 0, because if they're both 0, then dy dx is undefined, and I might be looking at a non-differentiable point of the function. All right, so let's see what I get. Negative square root 3 times square root 3 is going to be negative 3, and then 4 times 2 is 8. So, all right, yeah, it's 0 over 5. It's 0. So dy dx is 0. All right, but that's not what I'm supposed to do. I'm supposed to find the equations of the tangent and normal. All right, so I can get the equation of the tangent pretty easily. Now, I'm going to to go through the whole thing, but obviously there's an easier way to do it. Y minus 1 equals mx minus x1. This is how we get our tangent line. So I'm going to say y minus 2 is equal to 0 times x minus square root 3. All right, so it's just y equals 2. Now, what do I mean by an easier way? As soon as I see that the slope is 0, I know that the tangent is horizontal. And as soon as I know the tangent is horizontal, I know that the tangent has the equation y equals a constant. And what is that constant going to be? It's going to be whatever that y coordinate is. So that's the shortcut for getting the tangent. Now, when you go to do your normal line, what you would normally do, little joke I make, is you would go y minus 2 equals, and then you would use your negative reciprocal here, right? Here, opposite reciprocal, right? Negative 1 over 0, x minus square root 3. But oh my God, it's undefined. What am I going to do? All right, so what that means is the slope is undefined, but the line is not. Because the tangent was horizontal, that means the normal is vertical. What does the equation of a vertical line look like? It looks like x equals something. All right, and what is the x going to equal? Whatever the x is here. X equals square root 3. So when you get a horizontal tangent and you're looking for the normal by the usual method, the usual method's not going to work, because when your tangent is horizontal, your normal is going to be vertical. So the normal line is not going to be expressible in this form. This form assumes that the normal is not vertical. So now that we know the normal is vertical because tangent is horizontal, we can go back and just pull the x from there. Okay? Maybe we'll look at one more example.